we have Chepurnyi, which will be doing his talk today on performance consultancy. Well, you're a performance consultant, right? I've been actually looking at your YouTube channel over the last couple of days. Must say, there's a lot of content there.
Yeah,
so
great to hear you took a look at some of my videos.
Yes,
most of
definitely.
them are old. Year without no uploads, so yeah.
Yes. So I remember when you talk about blame me for Magento 1 issues, and I was like, well, if somebody is on Magento 1, I don't know if they can blame you, right?
Yeah,
but
it's kind of a running joke because I was in a team of first 5 core developers who built the platform in Kiev.
Yes. Wow. I know you go way back. I'm looking at that. But I got a bit of thing. I was told that you are the world's best performance optimization expert. And one of those folks you could describe as a genius. That was what I was given to as an intro for you. So you have a lot of expectation in this one, my friend.
Oh, it's kind of flattering for me what you said. You know, like I never consider myself the best because, you know, like there's always a place where you still can evolve yourself in.
That's nice. Well, I'm gonna leave me out, and I'm gonna get you going, and make sure you get on with this fantastic talk we're looking forward to.
Thank you very much. So can I start? Right?
Yes.
Okay, great. Hello, everyone. Thanks for joining the talk. I saw like this morning there is talk after talk. Everyone talks about performance, and you know, like this talk is gonna be the same thing. So sorry for that if you expected something different, but performance is kind of a pain point in our community because a lot of things are not going as well as they should have with Magento 2. So I'm going to talk about optimizing Magento specifically from the backend. So if you are not a backend developer, it might be a little bit hard for you, but I think you will gain some concepts for yourself that you can then tell your
good.
that will you will share later on for your other team members. So let's start with a small disclaimer. I'm not going to talk about cache optimization, or neither I'm not going to talk about cache pre-warming. So this talk is going to be about the way how to actually improve uncached pages of Magento, and I'll touch a little bit some details about issues with Magento cache. So let's start actually with issues right away. So what kind of pitfalls we have in Magento with the cache? First of all, there's a lot of variables when you have a customer within your page that affect your cache and can invalidate it. So for instance, let's take a look at the category page. So you go there, it can be logged in customer, it can be a wholesale customer, it can be retail customer, it can be customer from these countries that wants to see data in this currency. It can be affected by the current date because you might run a promotion. So the cache is very volatile and it changes all the time. And there's so many variables affecting uniqueness of the cache. It's sometimes very hard to grasp. And it's one of the pitfalls of using cache to optimize your performance. Another one is when you have so many variables, updates of the cache are very slow in the backend. So you go to update your product, but this product would have 1,000 entries in cache. So Magento would have to go through the cache storage and clear every of these 1,000 of records in the storage. Then, because you have so many products, especially if you have like 100K and more products in a catalog, your cache memory usage will grow dramatically over time because more and more cache entries will be added as more pages are visited, as more pages render products, and so on. Another thing is I call cache onion, and I call it nightmare because you can have a situation where one of your cache depends on another cache, and then it's all cached in full page cache. And then you have a huge onion and you need to peel it out, and you need to make sure that invalidating one cache also invalidates all the other caches. And that's why caching is kind of very hard way to optimize your software. So usually if there's other options, I would prefer not to go for cache. So question is, but do we really need to have this granular cache that we have in Magento 2 on pages? Let's take a look at a normal category page of a normal fashion retailer store. So we can see here is a lot of parts of the page. I will leave a small exercise for you, just maybe to guess in which parts Magento actually caches the data. Just give you like 10 seconds maybe, and then we switch and I'll explain which parts are actually cached in Magento. So are you ready? Okay, so I'm gonna switch to the next slide, and here you can see that, for instance, we have this top menu. The top menu is a list of categories that Magento caches for every single page, and it retrieves it from cache in order to not generate it every time. Then we have also our product list. And what is a huge problem, in my opinion, that Magento caches every single price of the product. So every single product that is rendered on a category page or a product page, except shopping cart, is actually cached. And Magento uses Redis to store this data. So your cache actually grows with the number of products you have. This is apart from the issues like layout caching that is also unique per each page you view. Then we have footer. And footer is kind of strange thing for me why Magento caches it, because footer doesn't involve a lot of complex computation over there. And there is also somehow copyright is cached. Maybe copyright is, oh, sorry. Oh, did I switch too much? Okay, sorry. Won't touch my mouse again. So here we have also copyrights that been cached, and this is kind of weird thing, like why do we cache copyrights at all? So let's go further, like why Magento does use cache, except parts that it shouldn't use for. First of all, let's take a look at the top menu. So if you profile your page without enabled block cache, you can see this kind of graph in Blackfire, where you will see that for each category in the menu, Magento tries to retrieve the category URL, and retrieving this URL involves a database operation. So if you have hundreds of categories, it's going to be hundreds of queries just to retrieve that URL. So you can see it quite well here, right? So you can see a lot of those boxes, and each of them is actually an IO operation to retrieve the data from the database. Another one is on the product list. And as I mentioned, Magento caches prices. But majority of the issues that exist there are related to configurable products. So if you have a configurable product, Magento will load every single simple product assigned to this configurable product and will iterate through it. And then it will execute database queries in order to find out what is the price of this simple product. So it does a lot of redundant stuff there. So Magento just put a cache on top of it. This kind of problems, they have a nice name in our community. We call them load in a loop. However, outside of Magento community, it's better known as N+1 problem. N+1 problem, it's a problem of working with databases or any kind of storage where you execute a query for each item in a result of the previous query. So this is kind of known problem and known anti-pattern. And unfortunately, this anti-pattern is not catched by Magento core and not fixed in Magento core because of some of the things that I speculate about. That is the reason for it. One of them is introduction of successive abstractions. So developers just don't see what's happening behind all the services they use. And they don't know, okay, let's say calling product repository with get method will actually execute a lot of heavy operations in the background. Another one is promotion of singular service access by Magento. Why I mentioned promotion? Because Magento has a very easy way to access a product by single ID, but if you want to access product by multiple IDs, you can do it only through the getList method, where you have to instantiate a search criteria and you have to configure filters. And this is much more complex. So developer will always choose something that is simpler to access than something that is more performant, but much more harder to get data from. Another one I think, is that the system is designed from the bottom up. So it's designed around how you have your data structured in the database, not in the way how you actually access this data from the user endpoint. And this can lead to a lot of bad decisions like singular access, because you never think about accessing a list of products instead of accessing products one by one. So the question is, can we actually fix it without modifying the core code? And why I'm talking about fixing without modifying the core code, because in my experience, doing it for the pull requests, first of all, it's going to be a backward compatible change. Another thing is that processing pull requests is getting harder and harder with every year. And with the recent changes, it's even more harder. So we actually can do it without modifying core and with the minimal customizations. So let me explain a little bit. First of all, you can actually observe load events on collections that might cause n+1 database load. So you can observe those load events, and then you can load the data for those items in a collection. And you can create a plugin around a service that triggers n+1 problem. So in such a way, you kind of cherry picking the places where Magento is slow, and you just preload the data for that collection. However, doing it manually for every single collection type is kind of hard. So that's why there is a module for that. So I created a module that would make it much more easier for you, at least for products. You can find this module at this URL. It's on GitHub. It's still doesn't have 1.0 production version, but it's getting there. There is a branch called Road to 1.0. So how to use this module? First of all, you need to implement a data loader interface on your custom service, and you need to implement only two methods. One method is called isApplicable. Sorry. One method is called isApplicable, and inside of it, you receive a type. And type is a string variable that you can compare and check, hey, what kind of type of data I need to load? Right now, this module supports three kind of data types for product. One is list, when you are accessing lists like product listing on categories or related products or cross sells, anything that can use data from indexes that doesn't rely on most up-to-date data in EAV storage. Another one is cart, where you actually need to access the data as fresh as possible. And another one is other, where I don't know in which category to put that collection in. So you have three of them. Maybe in future there will be more. Another thing is there is a load method, and load method accepts a scope filter that contains data like, hey, what is the current store? What is the current website? What is the current customer group? So you can apply those filters to your queries to load the data. And then you have an array of product wrapper objects that contain product ID, product type, and product SKU. Everything that you need to load additional data for a product itself. Then, when you implemented this data loader, you need to register this loader as a dependency in the XML for the loader service that is provided by this extension. You need to remember the key by which you register this loader, because you will later on use it in your plugin. And inside of plugin, you will use this loader service for accessing data with two methods. One is get, which you pass an ID of the product, and you pass a key with which you registered your service itself. And then you have a has method that will be used by you if you want to make sure that this specific product, this specific ID, and for this specific data has been triggered by isApplicable and load method. However, if this product was not applicable, it will just return false. So you can just fall back to original implementation of Magento in order to not return the wrong data to the places where you don't expect. So let's take a look at the example of the implementation for configurable products. In this slide, because we have not much time for a presentation, I won't go through every single code available in a module, but later on in a GitHub, you can find the complete implementation with all the optimizations of multiple places of configurable products. So we'll take a look here at the prices. So what is the target goal of the module itself? First of all, we want to remove all the load and the loops for the price retrieval. So we want to make sure that the price retrieval only triggers one database query for all of the simple products with all of the configurable products that are shown on a current list of products. Then we want to remove load and loop for inventory check. We don't want to trigger a database operation for every single product within every single configurable that is over there. And another thing, we want to achieve a target number of below 90 database queries on category page with configurable products. Because if you ever work with Magento, you will notice it's almost impossible with the standard functionality. As soon as you have at least few configurable products, you will have your queries blow up. And for simplicity reasons, in this example, we're not gonna use the product status in our database queries, but in production, you probably should use it when you will develop your own module. So here is an example of the loader for simple products with prices. So you can see our base class with two methods, load and is applicable. Load method is omitted for now. You have this data key. It's just going to be a constant we will use later on in our plugin. Then we have the resource connections. It's how we're going to talk with Magento database. Then we have this load method that receives filter and array of products. And then we have this applicable is applicable method. And this is applicable method just checks, hey, is this product a resource that we're trying to load? Is it a product list? If so, then it's applicable. If it's not a product list, then not. Because for configurable prices, I want to load data from indexes only when it's a product list that needs data from indexes. So let's dive deep into the load method. The load method starts with aggregating all the IDs of the configurable product. So we just iterate through all of the products, check, hey, is it a configurable product? Yeah, okay, we add this ID to the list. And then if there is no configurable products, we are not doing anything more. We just return an empty array. And basically, we don't do any database operation if there is no configurable products in our loader. Then we aggregate connections, price indexes, and relation table in order to retrieve the data. So those are main data tables we're going to use for this example. Then we just build a simple query. And the simple query is going to be from this price index table that contains final prices of all the simple products. We join to it a relation table by using the product ID join on index entity ID. So product ID, it's our simple product ID within a relation to a configurable product. Then we retrieve columns, and as the entity ID of the result, we actually take an ID of the configurable product. So this is a column in relation table called parent ID. Then we just aggregate our price by using the minimal price across all of the index records of the related simple products. And then we have a final price that will return minimal final price across all of the simple products. Difference between price and final price in this index table is that price is the original price of the product, and final price is the price after applying all the possible discounts and promotions currently running in your store, like special price and catalog rules. Then we also group this query by using the configurable product ID. We say, hey, we want to receive this data only for the product IDs that are supplied in this configurable product IDs array. And then we filter our index by customer groups that we have from a filter that came into our method, right? And then we also apply a website ID as a filter parameter. And then we use a very nice method available in database abstraction layer of Magento called fetch a sock. And fetch a sock actually generates for you an array keyed by the first column returned from your result set. So you don't need to walk through the array yourself, and you don't need to aggregate values by some columns. You can just make it first column, and then you can use fetch a sock method on a database abstraction layer. Then we're gonna go to our plugin. So this is a plugin around the configurable price resolver. And this configurable price resolver gonna take the saleable interface that is actually a product in Magento, There is a small problem with Magento. What I don't like is that Magento sellable interface tells that getID returns us an integer. However, Magento returns us a string. So we always have to cast this value to an int. It's a little bit of inconvenience, but we can work around it by just creating a variable and only single time casting the value. Then we check, hey, do our service has the data for this product with the data key constant we've defined previously? If so, then we're just gonna return a float value for this product from the final price field. And if there is no such field, then we just return 0. So this is the default behavior that Magento uses for resolving a price. So if there's no price from simple product, it will just return 0 too. And then if there is no data was preloaded, then we just proceed to original functionality of Magento that will do this load in the loops. But usually, if we are working on product list, it doesn't trigger this method in any other place. And here is our DI configuration. As you see, the name of the loader's key is configurable price, the same as the constant we are using over there. Then we specify our loader itself, and then we just define a plugin. So quite simple customization. However, it has some great results. So the rest of the loaders you can find at the end of the presentation in a link to this module. So let's take a look at some numbers, right? So what's the difference? You can see that at least 34% lower CPU time versus Magento uncached page, 62% lower I/O time. And this number is astonishing, like it's 349 database queries less. And this is on a page with 50 configurable products shown on a category page of 200K catalog. So this is kind of huge improvement because we reduced by 75% our load in the database. However, this doesn't give us the whole story, like it's a single uncached page. So how it performs under the load? Here is some small load tests on my local machine without, like any servers, just to show you the difference itself. So I compared actually both solutions. I compared the cached price solution from Magento Core, where we have the cache enabled, the disabled cache for prices, then the data from the optimized functionality, and then optimized functionality without some additional things that I just disabled because they don't make any sense. But there's not much difference was in those results. So you can see here that the minimal response time of the cached page is still more than the time from the optimized thing. And of course, uncached page is always tends to go to 400 milliseconds in response time. The maximum response time, however, on a cached page is even higher than on a cached price is even higher than on uncached price. And this is mostly because Magento is using locking for block HTML cache. So if you have multiple requests that try to update the same cache entry, Magento will introduce some waiting mechanism, and then you receive actually this kind of worse performance results than when you don't have a cache at all on a max response time. And we see the optimized one tends to go a lot more faster than the one with the cache and without the cache. And the average response time for cached version versus optimized version and optimized with no identities is basically within the margin of error from each other. The same goes for 19th percentile and 95th percentile. So they both are almost the same. Only uncached version is outlier because, yeah, it doesn't have any optimizations at all. It just does loads in the loops. So what kind of key takeaways we can take from this example and solution we've implemented? First of all, you need to avoid using cache for data within a cached page because it doesn't make sense. It makes your software more complex. You need to worry more about flushing that cache than like getting any benefit from it. Another thing, you need to use single queries per set of data. Don't think that, yeah, you can put a cache on top of it and your loads and loops are gonna make like your life easier when it's cached, because in the end of the day, the cache invalidation is much more complex than just having the data being properly retrieved from the database. Also, I advise when you develop something, disable block HTML cache and use Profiler on your day-to-day work to spot such problems. And another thing, use Profiler, because I know a lot of developers don't use Profiler at all, but Profiler, I think it's one of the most important tools that you can use. You can use profilers like Lighthouse for frontend. So if you are using it for frontend, why don't you use it for backend? For backend, there is Blackfire, there is Tidaways, there is, I think, even old versions of XHProf that you still can install for free. So there's a lot of tools over there. Don't hesitate to use them. And a little bit about the future plans of this module and in general, Magento performance optimizations that I do on the sidelines in the community. First of all, I want to make it plug and play module. I just want to make sure that, hey, I just install it for the composer and Magento is automatically optimized, at least in the core, right? Another thing, I want to create a common preloaders for the product data. Like I want to make sure that MSI quantity retrieval for shopping cart and checkout are as efficient as just inventory checks on category pages. I want to make sure that identities for full page cache retrieval for composite products do not cause loading a loop too. So I want to create preloaders for that one as well. I want to create also a preloader module for categories, because categories are also a source of loading loops, as we saw with the top menu. And one of the big projects I'm working on right now, if you follow me on Twitter, you probably know about the thread that I have about the setup BI compile, how it can be optimized and what benefits it can do for us. So this is also on future plans for me. I'm not sure when all of this stuff will be ready, because usually I'm busy with this thing when I don't have other work or I really want to work on it. But usually I don't have time at all. So it's kind of hard to progress on those things. But this is something I think people need to know what's in future might happen. Here is links to the project. Here is the example from the slides. Here is the preloader library, and here is my contacts in case you are interested in something. So, Dwayne, I'm ready for questions.
Thank you so much for that, Ivan. It's one of the, let's see, in terms of I'm just looking at the timing because we have 5 minutes. So I guess from the audience, I guess we can just make sure that they can follow up with what you said in terms of your Twitter handle and make sure they are actually watching some of these deep dive YouTube on YouTube that you've done. Like these examples that you've shown on this presentation are really good, and I can actually compare them to the ones that you did on YouTube. And I was like, if you want to know about optimization, you have to follow these channels. And from a backend point of view, making sure that you're using Profile and how to use it properly, I would say is probably the best advice that you could give. Is there any other advice you would give somebody in terms of optimization?
Yeah, I think don't be scared to look under the hood, because a lot of developers are afraid of touching actually Magento parts related to the database. So they think like, yeah, it's in core, it's not something that I can work with, but really there is nothing complex over there. And another thing actually is very important as well. Like I'm talking about reducing number of database queries, but it doesn't mean you have to write monster queries, because sometimes people write queries that are 100 lines long with a lot of joins, and this is not better than just having, let's say, 3 small queries that are much more simpler and easier on a database server. So there's a lot of places where people can use a little bit of common sense, I think, when working with the software. Don't expect that someone outside of your customer project will fix the problem for you in the Magento core, because the things that we see in our projects are different than the ones that Magento Core sees when they develop a product, because Magento has different database sets, they have different use cases, and they really need to have a lot of insight like we have when we work on real projects.
Yeah.
And they don't have it. So don't blame them for it. And to fix problems when you can.
Thank you for that. Thank you so much. It was a pleasure listening. And I know this one of the talks that I would be looking back at and be like, okay, that's why you did that bit. That's why you did that bit. So we'll definitely have some really great examples.